calculus students. So in this video, I'm going to go through the Chapter 2, Part 1 test review. Feel free, though, to skip ahead to whatever problem you're looking for that you need help with. I'm going to start with problem number 1. This comes from section 2.1a, where we learned about analyzing parabolas that are written in vertex form. Our question says, for the given function, find all those pieces. Before we start to find the pieces, you should label all parts of the equation first, because that kind of helps you know what pieces to look for. First, the front number is a, so -1 is a because it's in the front. H is the inside number, and K is the outside number. Now that we've labeled, we can just use our formulas to go through and find all these parts. The vertex is H, K. H looks like +4, but we learned that when you put it in the vertex, it's -4, because it's the opposite. And then K is 7. So that's the vertex, -4, 7. How to find the x-intercept is you just take the entire equation and set it equal to 0 to solve for x. Now we're just going to solve for x by subtracting 7 to both sides. And dividing by -1, because I'm trying to get those parentheses by themselves. I'll come over here and do that. So we have 7 equals x plus 4 squared. And that's a +7 because we divided by 2 negatives right here. To undo something that's squared, I'm going to take the square root of both sides. The square root of 7 is just the square root of 7. Don't forget your plus or minus there. Because we did take a square root, you need the plus or minus symbol. Now to get x by itself, I'm going to subtract 4 to both sides. So our x-intercept is plus or minus the square root of 7 minus 4, 0. And that is an ordered pair for that notation. Sliding on down, let's do the y-intercept. The y-intercept we find by plugging in 0 for the x. So back up here to the top, I'm going to take my function and evaluate it at 0. -1 is times 0 plus 4 squared plus 7. 4 plus 0 is 4, and 4 squared is 16. -16 plus 7 is -9. So our y-intercept is 0 was the x value we plugged in. When you evaluated that equation, we got -9. So that is our ordered pair, 0, -9. The next step is to use the intercepts along with the vertex to go sketch what this function is going to look like. And this is just a sketch. The vertex we said was at -4, +7, so somewhere up there. The x-intercept we found to be at plus or minus √7 minus 4. We don't know exactly where that is, and you would need a calculator to know where that is on the graph. But we do know the y-intercept is at 0, -9 on the y-axis. Just by knowing that and knowing that this is a parabola that's going to make a U shape, I'm going to connect the dots together to draw my sketch. That's what your sketch is going to look like. Now we can do the domain. The domain is left and right. Since the graph does go to the left and the right, the domain is -∞ to +∞. The range, the graph goes down, which makes it -∞. But the highest y value the graph touches is at 7 with a bracket. The last piece we need for this function is the axis of symmetry. The axis of symmetry is the equation x equals h. And h back up at the top We said that was -4. That's question 1. On question 2, we're doing the same thing as question 1. It says for the given function, find all of those parts. This also comes from section 2.1a. Before we start to analyze it, let's label all of the numbers. A is the value in the front, which is 1, because there's no number there, it's just 1. H is on the inside of the parentheses, and K is on the outside. The vertex is H, comma, K. H is +5 because it's the opposite of whatever's inside those parentheses. And then K is -6. So there's the vertex, 5, -6. The x-intercept we can find by setting the entire function equal to 0 and solving. To solve, I'm going to add 6 to the left and right side. Next, I'm going to take the square root to undo the squared function. The square root of 6 is just the square root of 6. Because we took a square root, there needs to be a plus or minus there. Now to get x by itself, I'm going to add 5 to both sides. So the x-intercept is plus or minus √6 plus 5, 0. And that is written as an ordered pair because it's an intercept. To find the y-intercept, we're going to plug in 0 for the x. So g of 0 equals 0 minus 5 squared minus 6. Now we can simplify that. 0 minus 5 is -5. And -5 squared is 25. Minus 6 is 19. Written as an ordered pair, the x was 0. When we evaluated at 0, we got 19 for the output. So 0, 19 is the y-intercept. Now using those pieces, we can sketch what this function is going to look like. The vertex was at 5, -6. 1, 2, 3, 4, 5, 6. That's the center of that U-shaped graph. The x-intercept, because we had the square root of 6, that really is not going to help us a whole lot unless you had a calculator. Now the y-intercept, though, we know is at 19, way up here. Just by knowing those two parts, we can go ahead and sketch our function. The u is going to be pointing upwards like that. So that is how your function is going to look when you sketch it. Since this graph goes to the left and right, the domain is -infinity to +infinity. The range, the lowest y value is at -6. The highest y value is at +infinity. The last piece we need is the axis of symmetry, which is the equation x equals h. And h, we already established up above, was +5. So that's a little bit of review for you over section 2.1a, where we learned about analyzing parabolas. On questions 3 through 4, we are asked to do the same thing that we just did. We're going to analyze our quadratic functions. The only difference, though, is 3 and 4 are not written in vertex form. So we are going to complete the square. That was a method we learned about in class, to convert each equation to vertex form. Because currently 3 and 4 are both in standard form, and we need to convert them to vertex form so we can analyze them. Let's start with question 3. Our function says h of x equals x squared minus 4x minus 12. To complete the square, the first step we talked about in class was label all of the terms a, b, and c. Next, I'm going to move the constant over to the other side by adding 12. So that h of x plus 12 equals x squared minus 4x. Next, we're going to check to make sure the front term is a 1, which it is, so that's good there. Now we're going to complete the square. Completing the square was halving the middle term. Half of negative 4 is negative 2. Square it and add it to both sides. Negative 2 squared is positive 4. So I'm adding that to both sides. Now we can simplify. 12 and 4 is 16. This right side factors into x minus 2 using the shortcut we talked about in class, and that's squared. The last step is to solve for h of x by moving 16 to the other side. So h of x is on the left. X minus 2 squared minus 16 is on the right. That's how you write that equation from standard form into vertex form, by completing the square. If you struggled with that, that is from section 2.1b, where we talked about the process for completing the square. Okay, now that we've got the equation in vertex form, we can analyze all of the parts. Starting with part A, our question says find the equation in vertex form, which we just did that on the previous slide. H of x equals x minus 2 squared minus 16. Now I'm going to label my variables A, H, and K. The vertex is H comma K. H is the opposite, which is positive 2, and K is negative 16. To find the x-intercept, I'm going to set the entire vertex form equation equal to 0 and solve for x by adding 16 to both sides. 16 equals x minus 2 squared. To undo that squared part, I'm going to take the square root. The square root of 16 is plus or minus 4. Equals x minus 2. The last step is to add 2 to both sides. That is your x-intercept. Plus or minus 4 plus 2. That is an ordered pair. Plus or minus 4 plus 2, comma 0. I'm going to go ahead and split that apart because 16 had a perfect square root. We can actually simplify this. Positive 4 plus 2 is positive 6. And negative 4 plus 2 is negative 2, comma 0. So those are our two x-intercepts. The next question states, find the y-intercept. That is found by plugging in x equals 0 into our vertex form. So that's what I'm going to do. H of 0 equals 0 minus 2 squared minus 16. Now to simplify that, negative 2 squared is positive 4. Minus 16 is negative 12. So the y-intercept is 0, comma, negative 12. Using the x and the y-intercept and the vertex, we can go sketch what our graph's going to look like. The vertex was at 2, negative 16, which is way down here at the bottom. Just kind of eyeball it there. The x-intercepts we found to be at 6, comma 0. So I'm going to go to 6 here on the x-axis and put a dot, and negative 2. And put a dot along the x-axis. The y-intercept was at negative 12 along the y-axis. Now that I've got those points, I'm going to connect them using that U curve to sketch what this parabola is going to look like. And that's a sketch. The domain is from negative infinity to positive infinity because that never changes for quadratic functions. The range, the lowest point here is negative 16. The highest point is positive infinity because it goes up from there. The last piece we need is the axis of symmetry, which is x equals h. So x equals 2. On question 4, we're given the equation k of x equals x squared plus 2x minus 8. This equation is not in vertex form, so we're going to need to complete the square again to write this equation in vertex form. First, we'll label A, B, C. Next, I'm going to add the 8 to the other side to move the constant over, which leaves me with x squared plus 2x over on the right side. Check to make sure that there is a 1 in the front, which there is, because there's a 1 there. We don't need to worry about factoring anything out. Now we're just going to keep going along with our steps. Half the middle term, square it, and add it to both sides of the equal sign. Now we can simplify. 8 and 1 makes 9. And the right side is x plus 1 squared, using the shortcut we learned in class. Remember, the shortcut was this halved term becomes the factor when you factor that right side. The last step is to solve for k of x by moving 9 to the other side. Now that equation is in vertex form. If you struggled with completing the square, this is from section 2.1b in your notes. Now that we've written the equation in vertex form, on number 4, we can go ahead and analyze all the parts. Part A says vertex form, which we just did that on the previous slide. K of x equals x plus 1 squared minus 9. Now I'm going to label my terms A, H, and K. The vertex is h comma k. H is negative 1 because it's the opposite of whatever's on the inside of the parentheses. And negative 9 is k. To find the x-intercept, I'm going to set the entire function, when it's in that vertex form, equal to 0 and solve. To solve, we're going to need to move the 9 to the other side first by adding it over. To undo that square root, we're going to take the square root of both sides, and the square root of 9 is positive negative 3. The last step to get x by itself, I'm going to subtract 1. So we plus or minus 3 minus 1 equals x, and that is how you write your x-intercepts. Because that was a perfect square, I was able to get 3 out. I'm going to go ahead and simplify this a little bit. Negative 3 minus 1 is negative 4. And positive 3, that was a positive 3 there, minus 1 is 2, comma 0. So this one came from negative 3 minus 1. And this one came from positive 3 minus 1. That was just breaking apart that x-intercept. So those are your x-intercepts. Negative 4, comma 0, and 2, comma 0. To find the y-intercept, I'm going to plug in x equals 0 and solve. So k of 0 equals 0 plus 1 squared minus 9. When you solve that equation, k of 0 evaluates to be negative 8. And that is your y-intercept, 0, comma negative 8. On part E, now I'm going to use those intercepts and vertex to sketch what this parabola is going to look like. The vertex was at -1, -9. So here's -1, 6, 7, 8, 9. -1, -9. The x-intercept was at -4, 0 along the x-axis, and +2, 0 along the x-axis. The y-intercept was at 0, -8 along the y-axis. All right, now we got our points. Just connect them together to sketch what the parabola is going to look like. And there's our sketch. The domain is -infinity to +infinity because it goes left and right. The lowest y value this graph includes is -9. And then it just increases upwards, so it goes to +infinity from there. The last piece we need is the axis of symmetry, which is x equals h. And h here, we already established was -1. So x equals -1 is the axis of symmetry for that equation. That's a little bit of review for you over completing the square to write an equation in vertex form. And then from vertex form, we were able to analyze all of its parts. On questions 5 through 6, our question states, for the following, find the vertex using the vertex formula. This will be provided to you on your test. And this is the kind of formula we talked about in class. To find x, we're going to take -b and divide by 2a. Then once you find that x value, to go find y, you're going to take that x value and plug it right back into your function. So take this x and plug it in. And that will get you your vertex, x comma y. Let's start with question 5. Question 5 states q of x equals -2 x squared plus 4x plus 6. I'm going to label my variables a, b, and c. To find the x value of the vertex, I'm going to take -b, which is 4, divided by 2 times a, which is -2. Now we're just going to simplify that. 2 times -2 is -4. -4 divided by -4 is +1. So x equals +1. That's our first value in that ordered pair. Now to go find y, I'm going to take this and plug it back in for all of the x's. So q of 1 is -2 times 1 squared plus 4 times 1 plus 6. Now we're just going to evaluate that. 1 squared is 1 times -2 is -2. 4 times 1 is +4 plus 6. -2 plus 4 is 2 plus 6 is 8. And that was the missing part of that ordered pair. So the vertex is 1, 8. On question 6, we're doing the same thing. We're given the function n of x equals 3x squared plus 5x minus 4, and we're asked to find the vertex of that equation. First, we're going to label a, b, c. To go find x, I'm going to plug in b as -5 over 2 times a, which is 3. 2 times 3 gives us 6 in the denominator. So the first value in the ordered pair is -5, 6. To go find the y value, we're just going to take -5, 6 and plug it into our function. 3 times -5, 6 squared plus 5 times negative 5/6 minus 4. To simplify this without a calculator, we're going to need to follow order of operations, starting with the exponent. Negative 5 squared is 25, and 6 squared is 36. I'm going to change that 5 to 5 over 1, just to make it a fraction. 5 times negative 5 is negative 25. 1 times 6 is 6, minus 4. Since you are not allowed a calculator on this part of the test, cross-simplifying is really nice to use, right here with this 3 and 36. So I'm going to divide both of those by the common factor 3. 1 times 25 is 25 over 12, minus 25 over 6, minus 4. To subtract those fractions, we need to get a common denominator between all three. And that common denominator is going to be 12. The first fraction has a denominator of 12, so we can leave it. The second fraction, I'm multiplying the bottom by 2 to change that to a 12. So I'm going to multiply the top by 2. The third fraction, I'm multiplying the bottom by 12 to change it to a 12. So I multiply the top by 12. Now that those have common denominators, we're ready to just simplify the top. 25 minus 50 is negative 25 twelfths. Minus 48 twelfths combines to make negative 73 twelfths. That was the output we got when we plugged in the x. So this is the vertex of that equation. If you struggled on those fraction problems, I would recommend going back and looking at section 2.1a, where we learned about the vertex formula. And again, I will give that to you on the test. On question 7, the question states, for the given function, describe the transformations needed to graph it and graph the parabola. This is our function, f of x is negative 3, x plus 2 squared minus 1. First, let's talk about some of the changes that were made from the parent function, the quadratic function. The negative in the front tells us to reflect the function over the x-axis. The 3 in the front tells us that there is a vertical stretch by 3. The reason that was a stretch is because 3 was bigger than 1. We learned in class with the rubber band that vertical stretch makes a graph narrow. The inside, the plus 2, tells us to shift the graph 2 units in the opposite direction, which would be to the left, because that's the inside of the function, the x plus 2. We shifted it to the opposite direction, which is to the left. And last is the minus 1, tells us to move the graph down 1 unit. Now that we've got all the transformations, let's sketch what this looks like. So over here to the side, normally we start at 0, 0, but this graph is going to reflect over the x-axis. So we know that that makes it flip over. It is going to be narrow. I'm going to shift from the origin 2 units to the left and 1 unit down. Okay, we already said that it is reflected, which makes the graph go down, and narrow because it was a vertical stretch by 3. So that's a sketch of what your graph is going to look like with all those changes. The last 2 questions on your test review are over the concept that we covered yesterday in class about quadratic regression equations. So I'm going to do those in the calculator right quick. On number 8, we first need to enter all of that data into our graphing calculators. How we do that is we go to Stat, Edit, And then you want to clear out whatever's already in there. So just arrow up and click clear, and that will clear both columns out for you. In L1, we're going to enter all the X values, 25, 30, 35, 40, 45, 50, 55, 60, and 65. L2 is all of the values in the bottom row of that table, in the M of X row. 20.7, be careful with your decimals here, make sure you get the decimals in there too. 24.4, 27, 28.4, 28.7, 27.8, 25.8, 22.6, and 18.3 is the last one. Now to find the quadratic function, we're going to go to Stat, over to Calc, and down to Quad Reg, which is number 5. Click Enter. Go down to Calculate, so that way it calculates the equation for you. And that is the quadratic regression equation for that data. When you write this out, make sure you have y equals. A is this decimal rounded to 3 places, plus B is this decimal rounded to 3 places, plus C is this decimal rounded to 3 places as well. So when you round that, your equation is y equals negative 0.023 x squared plus 2.008 x minus 15.146. Now we did question 8, let's go do question 9. We're going to do the same thing. First go to your Stat button, Edit. We need to clear out those columns so we can put the new columns in. In L1, we're going to write all of the values that are in the T row. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, and 96. In L2, now we're going to enter all of the values in the bottom row, that y of t, starting with 0.57, 1.19, 1.50, 1.67, 1.95, 2.11, 1.95, 1.82, 1.54, 1.27, 0.61. Last one is 0.23. Enter. Be careful with all those decimals. Now that we've got the data, let's go get the equation. Go to your Stat button, over to Calc, and down to number 5, Quad Reg. All the way down to Calculate, and that is your quadratic regression equation. A is right here, B, and then C. So the equation is y equals negative 8.36. This e to the negative 4th, that was the scientific notation we talked about in class. So you'll need to say times 10 to the negative 4th after this decimal is rounded. And then x squared plus 0.082x plus 0.012. We're rounding all of those to 3 decimal places. So just to recap what we did in the calculator, we plugged in the data for question 8 and got the equation. y equals negative 0.023 x squared plus 2.008x minus 15.146. On question 9, we did the same thing. We plugged in the data to our calculator, and we got the equation y equals negative 8.36 times 10 to the negative fourth. And that was all multiplied together, and then t squared is on the outside, plus 0.082t plus 0.012. Besides getting the equation on question 9, we also have an additional part. Our question asks us, at what time to the nearest hour is the yield the greatest? Since we want to find when the yield is the greatest, that indicates that we're finding the maximum value in this quadratic function. And we want to know specifically what the x is because that is the time. To go find the maximum value in this quadratic function, we can actually just use the vertex formula, negative b over 2a, because that's going to give us the maximum value that is the x. Let's just plug that in. Negative 0.082, because that's b here, over 2 times this value, which makes up a. Make sure that all goes in parentheses, by the way, when you type that into your calculator. When you type that in, you're going to get a decimal that is close to 49. And that is your answer. At what time to the nearest hour is the yield the greatest? The yield is the greatest after 49 hours. And that's the end of our test review. I hope that was helpful in going through the key concepts we've learned throughout this part of Chapter 2. If you have further questions, the test review key is on Canvas, but please also email me if you need help with anything that's on the test review. Have a great day, Huskies.